Dear NCA students, this is Joe. With this video, I'm going to cover Lab 2, Designing and Implementing a Subnetted IPv4 Addressing Scheme and Basic Router Configurations. Okay, for the Lab 2, we'll give you a background scenario. Okay, for Lab 2, we'll give you a single IP address, which you have to use it to create multiple subnets. Okay, subnets mean networks. So why we create networks? Because we want to have multiple groups of users, maybe in our organizations or in our classrooms. For that, we have to use the subnetting techniques. Okay, so without subnetting, you are allowed to use only one subnet, which is what we use it in our homes. Okay, in our homes, you don't need multiple subnets, so we are just using one subnet for our home. So there is no subnetting required for our home usage. Okay. Okay, we give you some design requirement for our Lab 2. So first, step 1, we have to create subnetting scheme that meets the required number of subnets and required number of host addresses. Okay, so as I mentioned earlier, we will assign you an IP address which is 192.168.0.0. Okay, with /24, which means you will be given a 24 network bits here. Okay, so you must take note. In the typical IP address like this, we have combinations of network and the host bits. Okay, in the IP address, we have total of 32 bits. Since I already mentioned, they have 24 network bits, so 32 minus 24, so we left with 8 host bits here. Okay, again, this is your network bits, and this will be your host bits. Okay. So our next requirement will be we have to create a first subnet for employee network, which need a minimum number of 25 host IP addresses. Okay, maybe this IP for laptops, PCs, or mobile phones. Okay, and second subnets for admin. So we need total of 10 IP for that. Okay, take note. And you have to create a third and fourth subnets. Okay, which are reserved as a virtual networks. Okay, which is not physically there, but it's just a virtual networks resides on the router as a loopback 0 and loopback 1. Okay, and you also need 2 additional unused subnets for future network expansions. Okay, so from the requirement, what I understand is we need to use 6 subnets total. Okay, so note variable length subnet mask will not be used for this particular lab, which will be using this in the Lab 3 onwards. Okay, so along the way in the lecture, I will tell you why we use VLSM. Short form, variable length SM is VLSM, which is better compared to our normal subnettings. Okay, without further ado, let's answer a few questions here. Okay, questions say how many host addresses are needed in the largest required subnets. Remember, in the first subnet, this is the largest number of hosts required, so it's 25 hosts. Next, what is the minimum number of subnets required? So we need total of 6 subnets, as I mentioned earlier. Okay, let's talk about our IP address which is given, which is 192.168.0.0 with /24. What does this 24 means? Again, as I mentioned, 24 means we have total of 24 ones, and then remainings are zeros. So what are these 1 stand for? This is next questions. What does it 1 represent over here? So this 1 represent what is a network bits. How about zeros? How about 0 represent? So 0 bits represents the host bits. Okay, host bits are the bits that we can be used for assigning our laptops, PCs, and our networking devices. Take note, these network bits cannot be touched. Okay, for whatever reason. As for subnetting, right, we do have to do some calculations based on the required subnets. So remember, bear in mind, we need total of 6 subnets for our Lab 2 today. Okay, there is a very quick formula. Let's say example, today we need 6 subnets. Okay, so how many bits you have to borrow? Okay, there's a formula for that. You have to borrow the bits, meaning that without borrowing, you can create a subnets. Okay, so what does it mean by borrow? Okay, let's say example, this is my IP address which is given, okay, previously. Okay, okay. So now, example, when we use /25, which means out of 24, we borrow additional 1 bits. So you see, this 1 bit is we are touching the host part. Okay. So once I borrow, right, what I can do is I can create two subnets. Okay. Okay. So by borrowing 1 bit, I can create 2 subnets. Okay. There's a formula applied here. Let me write here. Okay. Let's say if I borrow 1 bit, borrow 1 bit, I can create 2 subnet. Okay. What if I borrow 2 bits? I can create 4 subnets. What if I borrow 3 bits? I can create 8 subnets. So take note, for today, we need 6 subnets. So how many bits should I borrow? 1. If I borrow 1, I only can create 2 networks or 2 subnets. So out. So how about 2? If I borrow 2 bits, something like that, okay, to borrow 2 bits here, I only can create 4. So out for today. What if I borrow 3 bits? Here, so I can create 8 subnet groups. But today we need only 6. It's fine if you have more, okay? Okay, so to get 6 bits, we have to borrow 3. So we need 3 borrow bits for today. So can So now let me go through this example here. Okay, let's say if I borrow 1 bit, I can create 2 subnets. Okay, as you see, once I borrow already, look at my host. My host get lesser. Okay. Okay, can. So if my host getting lesser, as you realize that, okay, my host now left with only 128. Okay. So in typical, I can use up to 256. How I get it? You see, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. Okay. Then you change all these to 1. So what you get is 255. Okay. So 255 meaning that, okay, we start from 0 to 255. That's why it's total is 256. Okay, but now I already borrow 1 already. So you only can use the remaining 7 bits. So if you use remaining 7 bits, you can go up to 128. Okay. So 128, then why minus 2? Because bear in mind, for every subnet groups, we have to take note of the beginning bits and the last bits. We have to minus away. So always is minus 2. Okay. So we can use 126. Okay. Host bits for this typical scenario. Okay. Okay. Next, this is your subnet mask. Okay, based on your borrow bits. Okay, so this one is 1111, 8 ones. If you use calculator, it will be 255, 255, 255, and if you use calculator again, you will get 128. Okay. Okay. With that knowledge, okay, now let's borrow 2 bits. If I borrow 2 bits, what happened? My /24 become 26. Why? 24 plus 2 is 26. So again, you use calculator, you get the new subnet mask, which is 255, 255, 255, and 192 here. Okay. So again, by borrow 2 bits, you can create 4 subnets with 62 hosts. Okay. So where does 62 come from? From this remaining host. Okay. Okay, and so on with the /27, 28, 29. So I leave it to you to digest and do it yourself. Okay. Can So as far as today the requirement is concerned, we have to use 3 borrow bits with this subnet. If you borrow 3 bits, right, you have to use this subnet mask for today, which is 255, 255, 255, and 224. Okay. Can. So bear in mind, by doing so, we can use up to how many hosts for today? 30 hosts. Okay, is it this 30 hosts for each subnet? Is it sufficient enough? Let's take a look. Our largest host we only use 25. So I think 30 should be more than enough, isn't it? Okay, Can. Okay, okay, with that, let's fill up the subnet mask required for today's scenario. Okay, subnet mask. Okay, so this will be meeting the minimum requirement. This also will be this will be meet for both. Okay, this is for subnet mask meet the minimum requirement of host addresses. Okay, this is the best. This is for require for number of subnets required. So 224. Okay, why 224 is basic because we borrow 3 bits. Okay, because we borrow 3 bits to create 6 subnets. Okay, for today's we need 6 subnets. Okay, so by borrowing 3 bits you can create 8, but we only using 6 only. So with that, let's fill up this form. This is basically to tell you that, okay, so this is a subnet 1 with this fixed or our subnet mask. We get it from today, borrow bits. After borrow bits, this is a new subnet mask. Okay, this will be your second subnet. So you see the pattern, 0, 32, 64, 96, 128, 160, 192, 224. Total we can get up to 8 subnets. Okay, so as I mentioned earlier, if I borrow 3 bits, I can have each subnet I can have up to 30. So you tell me, sir, how come from 0 to 32 I have 32? Why only say 30? Remember, our first bits and the last bits of IP address have to be removed, okay, which is used by the systems. Okay, so that's why we only left with 30 for each subnet. Okay, so I can give this first subnet to my first network, which is for employee. I can give this to second subnet, administration. I can give this to third and fourth, and I can use this too for future expansions. Okay, with that, I come out with this IP address for my today network. Okay, I'll explain to you details in our lab, in our lectures. Okay, so to make my video short, just let you know that I get this IP address through my subnetting. Okay, so now I'll show you how you can set up a network configuration using the simulator, which is a Cisco Packet Tracer. Okay, again, you can download this Cisco Packet Tracer from our Blackboard. Okay, our NCA module. Okay, so this is a software. Okay, on top you can see some menus here. You can create a new project. You can open the projects and etc. And then here you can get some simulated hardware devices. Okay, for example, today we're using 2 PCs, 1 switch and 1 router. Okay, so you can build a setup like this. Okay, now let's get a PC. So you can get a PC from here. Okay, so click on this end device. There's a PC. Click on here. Click on here. So we need 2 PCs for today. Okay, and then you can name the PC as PC A, and this one PC B. Okay, clear? Okay, next I need to use a switch. So this is a switch here. Take note, click. Then we use a switch 2960. Okay, 2960. We use a switch here. Okay, so you can name as a switch 1 also can, if you want to. Okay, the next one will be the router. So this is a router here. So click on the router. We choose today is 2811 router here. Okay, next is the wiring. So how to wire? So from PCA, I want to link up to switch 1. So this is a wiring. Take note, PC and the switch, they are different layer devices. Okay, so I will use a straight cable. Okay, so this is a copper straight through cable. So from the PC, we use Ethernet, connect to the switch. Okay, you can use any of the port from 01 to 024. Okay, don't use console. Console is mainly for the configuration. So we use first Ethernet 01 here. Okay, next switch to the router. Again, they are the different layer devices. So we use a straight through cable. So from switch, so let's see, since my first Ethernet 01 is occupied, so I can only start using from 02. So now I hook up to router, okay, which is FA00 here. So I choose fast Ethernet 00. Okay, see, I click this. Okay, next my PCB will be linked to router 1 again. Okay, so we'll be using think of a cable. Okay, now PC to router is using the same layer device. Okay, come back to the lab. Okay, now let's connect PC to a router. Okay, again, PC and routers, they are the same layer devices. So for that, we'll be using a crossover cable. Okay, So choose the crossover here, just dotted line, just click this crossover cable. Okay, connect to PC, fast Ethernet 0, connect to the fast Ethernet 01. As you see just now, there's 00, but now 00 is gone because 00 is used by the PCA just now. Okay, now I connect to 01. Okay. Can? Okay, let me check my video. It's going. Okay, good. Okay. Okay, next. My physical setup I have been doing quite okay. Done. Okay, next. Okay. Next, we're going to assign IP address to our computer, which is a PC. So to assign the IP, just click on the PC. Okay. So just now there's a warning message. You go to the desktop, IP configurations. Okay, there's a DHCP and static. So we're using static because we're going to assign manually for our IP. So our PC IP is how much? 192.168.0.2. 192.168.0.2. Okay, no need /27. Okay, subnet mask for today is, remember, 224. Why 224? Because we borrow 3 bits. It becomes 224. Okay, why borrow 3 bits? Because we want to create a total of 8 subnets, but we only use 6 subnets. Okay. The default gateway is 192.168.0.1. Okay. Okay, now how do you know the default gateway? Look at your router FA00, which is 0.1 here. Okay. Okay. So if you're done, no need to click save, just close this button. Okay. Okay, next I'm going to assign for PCB. So click on the PCB, go to the desktop, click on this IP config, static. The IP for this PCB will be 192.168.0.97. Okay. Sorry, 97 is for the gateway, so I can use 97. So I can use from 98 to 126. So I'll use 98 instead. Subnet mask will be 224. Our default gateway will be 192.168.0. So for the default gateway, I have to follow the FA01 IP address, which is 0.97. So you ask me why, sir, can I use .1 or not? If you use .1 here, it will be belongs to this part. Okay. Okay. So for today, we use .97. Okay. Okay. If you're done, just close it. Okay. Next, for the switch, you don't have to do anything. Switch is basically a hardware device. As for today. So next part will be the router part. So we have to configure the router. So we have to assign the IP address to the router. Okay, because router come with no IP, nothing inside. Okay, so to assign the IP, click on the router. So go to CLI, stand for Command Line Interface. Okay, this tab. Okay, so let's do the configuration here. Okay, so take note. Hope you can see from your screen. Okay, so first they ask you continue with configuration dialog. I will say no. Okay, because I want to enter manually for my IP addresses. So if you say yes, right, they will bring you to a wizard screen. So you have to answer some questions. Okay, so a bit troublesome to me. So I just want to do it manually. So I say no. So now you are in the router screen. So now what you can do is that you have to log into the router. So how to log in? You have to type enable. Okay, ENABLE enable. Sometimes you can use a shortcut which is EN. It's the same also. EN and enable is the same. Okay. So next, now I'm in the hashtag mode. So okay. So I'm now inside the router already. So this is still not yet, but now in the router already. Okay. Of course, you can set some password for that. Okay. Currently, my router has nothing, no password, nothing. So they will straight away bring you to the menu. So router menu. So now I need to start off with configuration. So shortcut is config T or config terminal. Okay. Or config T. T also can. Or terminal also can. Okay. So next I need to assign the IP address for my FA00. So to assign the IP, I type INT, stand for interface, FA, which is the FA interface for 00. Okay, enter. Followed by, okay, after you enter, right, you should see this IF stands for interface. Okay, without that you cannot key in any IP address. Okay, so bear in mind. Okay, can. So I'll type IP address. Okay, 192.168. Okay, Okay, what's the IP address for this FA00? 0.1. 0.1. My subnet mask for today is 255.255.224. Okay, so you must type IP address and follow by subnet mask. Enter. Okay. Okay, next you see my line for this connection is down, so you need to bring up the line. So how to bring up the line? Just type no shutdown. Okay, once you type no shutdown, you see here the light red color change to green light. So amber means is making the or establishing the connections. Okay, so do the same thing for the next interface, which is INTFA01. You ask me, sir, can I need to go back to configuration terminal? No need. Okay, now you're already in config T. You just type INTFA01. Or some people prefer to do that. Okay, if I type exit, they will bring back to the previous menu. Okay, now I'm in the configuration mode. So again, also same thing, you can type INTFA01. So now let's configure INTFA01. Okay, so next you see once I type in INTFA01, which is for this one, I can see this IF here. Okay, so my IP address is 192.168.0.97, followed by subnet mask 255.255.224. Okay, so next will be the key in no shutdown. So you see now is red color connection. So when I start to type no shutdown, you see the lights change to green. So that means the connection is up. Okay, next we need to assign, don't forget we need to assign for the loopback 0 and loopback 1, okay, which is for the third and fourth networks. So same thing again. So now I don't want to go back to exit, so I can straight away type from here INT. You can type loopback 0, okay, loopback 0. Or short form you can type L0 also can. Okay, followed by you want to assign IP address, right? Okay, see you can either type or you can call the previous data by using the up down arrow key. Now you see I press the up down arrow key, you see so I can just simply change my 0.1 to 33. As you see here, this is 33 is for the loopback 0. Okay, bingo. Then you can type no shutdown. Okay, next. So again I show you using the up down arrow key. Next I'll be using loopback 1. Okay, so IP address, again I'm using the arrow up down arrow key. Okay, so I'll change this 33 to how much? Loopback 01 is what? 65. So I'll change the 33 to 65. Okay, followed by no shutdown. Okay, bingo. So I've done all the configurations of IP addresses in our router 1. Okay, so I can check back whether I have keyed in correctly or not. So next to check, you have to exit from the current menu, exit, and you need to be in the router menu, which is the main menu here. Okay, so how to check? So the command is show IP interface brief. Okay, now you can see you have assigned the FA00, FA01 with this IP. Your loopback 0 is 33, loopback 1 is 65. So all are up now. Okay, up is equivalent to, you see the green lights. Okay, so how can we check the configuration whether it's working or not? So by just simply try to ping. So how to ping? Click on the PC. So now ping, ping ping is a command to check their connectivity. So now let's try to ping from my PCA ping to FA00. Let's try. So click on this command prompt. So type ping, you type your IP address or type the IP address of your FA00 192, which is 192.168.0.1. So now you see this reply from meaning this router 1 FA0 is replying the information back to your PCA. That means once I get reply from, that means my connection is established. Okay, next I can just use up down arrow key again. I try to connect to loop 0, which is 33. So I type 33. Yeah, I can also get the reply from 33. This is a virtual networks. How about 65? I use the up down arrow key. 65. again, I also get the reply from, okay, from this 65. Okay, you can see here from 65. Okay, last will be, I will be ping to the our last station, which is PCB, which is 97. Okay, there you go. Reply from PCB. Okay, so I have successfully done the connections and configurations using a Cisco packet tracer. Okay, by the way, if you want to move around the router switches, you can do so. Okay. Okay, let me end my video here. So for the remaining part of the lab, please go through it by yourself. It's basically to check whether your connection is done or not done. Okay, if connection is not there or you don't see a green light, you have to do some troubleshooting. Okay, so let me bring all the way up to the reflections. Okay, next you will see some Cisco command line that I used just now. Okay, this is you can get from your lab sheets also. Okay, this is some command line that I'm used just now. Okay, with that, let me end here. Thanks for watching. We'll see you next time. Okay, have a great day. Bye.